This is Dan, and this is the Napkin Academy. Our lesson is 6x6 picture type number 3, which we know is otherwise called a map. The picture that we want to draw when we want to show where something is a simple little map. Let's think for a moment back to our simple picture, how our visual system is processing what it sees. As we recall that when we looked out at an image, one of the first things we saw was what were the objects. We saw those, and that of course was our what pathway. And then we counted them. We saw numbers, which was our how much pathway. And now we're going to see the world a little bit differently, and it's happening at the same time. In this third pathway, what we're actually recognizing is the distance between things. And in particular, the distance of those things to us. So the world's going to look very different according to this where pathway. We don't care what the objects are. We have no ability to recognize them. All we care about is what is their location. And so in fact, what the world's going to look like, according to our where pathway, is much more like this. All we're going to see is a kind of a blobby shape with no regard for what it is, but tremendous detail for, again, the distances between all of those different things that are in front of us, and represented here by the differences in shading, whether it's dark, whether it's black or dark gray or light gray. What we're actually doing is we're not only, through our where pathway, seeing the world probably in this kind of grayscale image, but also using that to indicate the distance of things away from us and closer to us. So in fact, in this kind of schematic view of it, what we're imagining is things that are darker are closer and things that are lighter are much further away. So we've actually got a full three-dimensional set of visual position and location through our where pathway. So let's go ahead and fill out our specifics. We're talking about 6x6 picture number 3, which we call the map. Of course, an example of a map is I could draw you something that looks a bit like this. And although it is very rough, I'm guessing that most of us could probably, well, hopefully take a guess at what I'm trying to draw over here. So this is obviously a map of the world. I don't know how obvious that is. This is a map of the world. Let's remember Antarctica down here. So there's an example of a map. And of course, what we always add to a map is going to be important later on is we always do something like this that says north. In fact, it's interesting, isn't it? Because a map shows where. That's all it does. All it does is show where. And its coordinate system is obvious, isn't it? Because we already drew in the coordinate system. The coordinate system of a map is always a two-dimensional system in which we most normally say this is simply up or north and south or down and east or right and west or left, or some sort of 2x2, we're going to call this a 2x2 coordinate system in which we've got two things that represent distinctions, polar opposites from each other. The relationships of objects within a map is very simple. It's the spatial relationship of objects. That is to say, the things that are represented in our map, really more the blobs that are represented in our map, all we're trying to show is the spatial relationship between them. So that is to say, where are they in relation to each other in space? Where are they in space? The starting point for drawing a map, well, we could draw the coordinate system, but I think it's much more important when we're starting a map because we're concerned about where things are, that we just go ahead and draw the most important thing. First, the most prominent detail of the landscape. So if I wanted to make a map of Tokyo, I might first draw Mount Fuji and then say that the city lies at the foot of Mount Fuji and the water is off to the side. So when we draw a map, we simply start with the most prominent point on the landscape, and then de facto, eventually our coordinate system is going to become clear upon it. So let's talk about some examples of maps. We've seen one already. A most obvious example is simply a map of a place. And let's say that this is Treasure Island. Most prominent feature is the outline. And here's a volcano. And here's the bay, the lagoon where we park our ship. And here's maybe the native village huts. And the buried treasure is way back here. So this map tells us, with its coordinate system, where that treasure is buried and what pathway do we need to take to get to it. So that's kind of the most simple map. But you know, if we wanted to lay a grid on top of that map so that we could divide it up and make and be able to measure that island very, very specifically, we might drop a grid on there. And what we're going to end up with is something that looks a bit like a chessboard, which is another kind of a map, isn't it? And all we're saying is that the pieces are in these positions. Now, in this type of a view, we don't really care so much about the details of the pieces. Again, we're not really concerned with the what, but we're much more concerned with where are they located. So that's another map. And if we wanted to take that kind of a map and make it even more abstract, we could get rid of the grid altogether and just keep the coordinate system. And now we could make a coordinate system that said almost anything. It could be, let's say, rich and poor versus happy and sad. And then we could plot in, I'm sure there are happy rich people, and I'm sure that there are also happy poor people. And I'm guessing that there are a lot of sad poor people, and I know for a fact that there are also some sad rich people. So what we've done is we've further abstracted our map so that all we're really concerned about is really the underlying coordinate system and where, again, do the pieces fit within that coordinate system. Another way I could represent that is I could say that, you know, interestingly, there are some people in the middle who are somewhere between rich and poor, happy and sad, and they overlap with some of these. I could abstract this and I could say, well, there's another way to represent it. I could draw a map that shows just the overlap of things. And what I'm really interested in, and this again could be happy, and this could be rich, and this could be poor. And what I'm interested in this particular case is showing what's the combination of people. Here's the people who are happy and rich, here's the people who are happy and poor, and here's the people who are neither rich nor poor but still remain very happy. And that's probably where most of us are going to want to be most of the time in reality. And now we've got another type of a map, otherwise known as a Venn diagram. Venn diagram, invented of course by the good Dr. Venn, to show what is the overlap of ideas. And then we could further extrapolate that, further sort of simplify that, and we could come up with a map where what we're really interested in isn't so much the overlap of the ideas, but just their relative position to each other in the most abstract kind of a spatial way. And we could say that this was idea number one, and this might be, let's say color. Could be color. And this could be red, and this could be blue, green, orange, and a tiny bit of purple. That could be, and what we have there is it is still a map, but now it has a specific name. It's called a mind map. Really coined by a guy named Tony Buzan out of the UK, who was really curious on how people could remember things. So here's what I'm trying to share with you, examples of maps. You know, maps are going to be, without a doubt, our most versatile type of picture from the 6x6. You can see how many different types of maps there are already just in this set of quick examples. Let's divide them up. And you could also see that there was a bit of a progression between them. We came from the one that really just showed place to the one that put a grid on it to make it easier to measure place, to the one that just focused on the coordinate system, to the map that just focused on the overlaps, to the map that just focused on the underlying relationships. All of them are maps, and we know that because in the end all of them show one thing. They show where ideas are. I want to spend a moment on one of the types of maps we just looked at, something that's called the 2x2 or the quad chart. Now, if anybody spent any time in a big consulting company, you'll know that every time a project is approached, time is spent on making the quad chart. What is going to be the 2x2? The consultants are sitting around looking at each other and saying, okay, we've got a project, new project underway, and we need to make a presentation to the client soon. And we've got to come up with a good 2x2 to show the positioning of the client. And so we spend a lot of time making these quad charts, and we've already practiced a little bit. Let's do one that says things that are, what would be a good one? Things that are expensive, and then each time we build a coordinate system in a quad, we make the two extremes literally be polar opposites. You'll notice derived straight from a sort of a typical world map laid out flat. What are the poles? Well, up here and up here. So when we make a 2x2, we always start with polar opposites. So if on one extreme, up here in the north, we have expensive, well, here down at the bottom, we're going to have cheap or inexpensive. And what might we do for our east and west? Well, let's say that over here is things that are good, and over here are things that are bad. And now what we've got is our consultant's quad chart, our 2x2, and what we can start to do is map in where the ideas of our client are. So certainly there are expensive good things. That could be a diamond, for example. Are there any good cheap things? Well, yes, good and cheap, I don't know how you feel about it, but sometimes a nice old hamburger, not a very expensive meal, it could be good and cheap. That might be a hamburger. Are there things that we can think of that are cheap and are bad? Yes, are there things that are cheap and bad? Of course there are. We could think of a knockoff watch. Maybe this was going to be a really fancy watch, but now we've got a knockoff version that doesn't even work, and before we know it, bing, the whole thing has broken. And are there things that we can think of that are expensive and bad? Absolutely. Well, maybe opposite our hamburger, maybe we've one time been to a really fancy restaurant and we had just this super expensive meal, and for whatever reason, we had a terrible time. It was expensive and it was bad. So now that we've managed on this quad chart to lay out the four kind of extremes, we then apply and say, okay, so where are we? What is it that our client has? Where do we sit within this map? And more to the point, once we've identified where we are, where do we want to go? A quad map is really the type of map that we want to use when we're talking ever about positioning, strategic positioning, competitive landscapes, etc. So let's summarize some of this by talking about when do we use maps? Well, whenever we want to know where something is. So what might be examples of that? In a kind of a business context, we might say, well, where is the competition? And we don't necessarily mean, they're in Asia. What we mean is, where are they in that conceptual term? If this is some quad chart and we find ourselves over here, where is our competition? Are they in the same marketing quadrant as we are? Is that why they're our competition? Or are they in a different quadrant and they may offer the same product and that's why they're competition? We could also talk about, simply, where is everybody? Where are the markets? Where are the people? We know where we are. Where are they? Or do we know where they are? Could it be the other way around, that we know where we are, but we're curious about where everybody else is? So where is everybody? Where's the competition? Where is everybody? And, really what we're talking about is anytime we hear the word positioning, of course, we're automatically talking about drawing a map. That's why it's called positioning. And if we ever hear competitive landscape, same thing. Every time we hear the word landscape, what are we talking about? We're automatically talking about a map. Okay, other times we would use a map when the question is, where do all the pieces fit? Where do all of these pieces that I have fit? And there's sort of a corollary question to that is, what are all the pieces? If I'm not interested in the individual details of each individual piece, but what are all the pieces in aggregate? What are all of the different pieces that I have? I draw out a map, and then I say, okay, so where do they all fit together? Well, let's make some sort of coordinates. Let's make some kind of mapping and apply eventually some sort of coordinate system to this. And that says, okay, now I understand what all my pieces are and where do they fit. And of course, the last type is, now that I know what the pieces are and where they fit, where is the overlap? Where do things overlap? If we are over here and our market is over here and our competitor is over here, but another competitor is over here, where is it that all of the pieces overlap? So those are the big questions we want to answer by drawing out a map. Let's summarize. So what do we know about maps? Well, they're the kind of thing that we draw when we're interested in where things are. And so let's draw kind of an example. Back in, from the 1400s or so in Europe, the way people typically thought about the world was they thought, here's Europe up here. And underneath Europe is another big piece of earth called Africa. And over on this side is another big piece of earth called Asia. And for hundreds and hundreds of years, that was the model that was believed to be true. And of course, people from Europe wanted to get a lot of the good stuff that came from Asia because this is where all the spices were. This was where all the tasty stuff was. And there were a couple of ways to do it. You could go across the land, but that was slow and treacherous. So, wouldn't it be great if you could go by sea? But to get over there, you had to sail all the way around Africa, which was incredibly dangerous, and then sail all the way back. And so one fellow came along, and we know who we're talking about now. And he said, I have an idea. Imagine if, instead of sailing my boat this way, I sailed my boat this way. And since we do know that the world is round, in fact, it is true that people, even in Columbus's time, yes, this is Columbus, knew that the world was round. If I sail this way, eventually I'm going to come out here and I'm going to hit Asia. So that's what he decided to do. He took his boats, his 3 little boats, and he set sail with the full anticipation of arriving in what was called Asia or India. And as we all know, he bumped into another piece of land on the way, which, became known for the longest time as the place where Indians live, because this must be India. And he sailed home without realizing that, of course, what he'd actually stumbled upon was a whole new piece of our map. That's what maps can do.